which is question number 61. Let's read it. The volume of hydrogen gas produced at STP from H ions in a solution by certain quantity of charge is 44.8 liter. The mass of zinc, atomic mass is given, that is 65.3 AMU, deposited at cathode from Zn2 plus solution by the same quantity of electric charge will be. Student, for this question, we need to keep in mind that according to Faraday's second law, the number of equivalents of H2 is equals to number of equivalents of zinc. That means number of equivalents of H2 we can calculate, since we are given with the volume of H2 produced 44.8 upon 11.2, which is equals to number of equivalents of zinc, which is equals to W upon equivalent mass. Equivalent mass we can calculate by dividing the molar mass by n factor. So molar mass is 65.3 and the n factor is 2. So we can clearly calculate the mass of zinc deposited, that is W, mass of zinc deposited, that is W is equals to 4 multiplied by 65.3 upon 2, which is equals to 130.6 gram. That means the correct answer is option number 2. Moving to the next question, students, which is question number 62. The equivalent conductance of m by 10 solution of a weak monobasic acid Ha is 4 per ohm centimeter square per equivalent. The dissociation constant of the acid will be. We are given with the equivalent conductivity at infinite dilution of the same acid Ha, which is equals to 80 per ohm centimeter square per equivalent. Students, in this question we are given with an acid Ha which dissociates to give H plus and A minus. At T is equals to 0, the concentration of Ha is, let's assume, C, and here it will be 0. And at equilibrium, let's assume that alpha will be dissociated. And at equilibrium, the concentration of Ha left will be C minus C alpha. So the concentration of H plus will be C alpha, and that of A minus will also be C alpha. Now student will be calculating alpha. So alpha is equals to equivalent conductivity at concentration C upon equivalent conductivity at infinite dilution. Equivalent conductivity at concentration C is equals to 4, we are given, and the equivalent conductivity at infinite dilution is equals to 80, which is also given. So the value of alpha will be 0.05. Now we can calculate dissociation constant Ka. Dissociation constant is equals to concentration of H plus multiplied by concentration of A minus upon concentration of Ha. Let's put the values here. C alpha upon C minus C alpha, which is equals to C alpha square upon 1 minus alpha. Since the value of alpha is very small than 1, therefore 1 minus alpha is approximately equals to 1, and the value of Ka is equals to C alpha square. Now let's put the value of concentration and alpha in this equation. The value of concentration is 0.1. The value of alpha is 0.05. We have to square this, which is ultimately equals to 2.5 into 10 raised to the power minus 4. That means the correct answer is option number 1. Moving to the next question, students, which is question number 63. The number of electrons involved during electrolysis by a current of 1.6 ampere in 10 seconds is, we are given the charge on one electron is 1.6 into 10 to the power minus 19 coulombs. Student, we all know that Q is equals to IT. Here the value of I is 1.6 ampere and that of time is 10 seconds, which is equals to 16 coulombs. Now student, we can calculate number of electrons. Number of electrons is equals to charge upon charge of one electron, that is 1.6 into 10 raised to the power minus 19. Data is already given. Therefore, number of electrons is equals to 10 raised to the power 20. So the correct answer is option number 1. Moving to the next question, which is question number 64. Let's read it. The reduction potential of hydrogen electrode in pure water at 298 Kelvin and 1 atm pressure is. Student, first of all, I'm writing the reaction. 2H plus aqueous plus 2 electron gives H2 gaseous. Here we know that E cell of H plus to H2 is equals to E naught H plus 2 H2 minus 0.0591 upon N log pressure of H2 gas upon concentration of H plus whole square. Since we know that E naught for this reaction, E naught for hydrogen electron is equals to 0 minus 0.0591. The value of N is 2 log. The pressure here is 1 atm, and we know that for pure water the concentration of H ion is 10 raised to the power minus 7 molar. So 10 raised to the power minus 7 whole square. Student, it is very clear that this is equals to 0.0591 upon 2 into 14, which is equals to minus 0.41 volt. That means the correct answer is option number 1. Moving to the next question, students, which is question number 65. Among the following aqueous solution, the best conductor of electric current is. Students, we need to know that more is the number of ions produced in the solution, more is the conductivity of the solution. So here it is very clear that sucrose and urea both are non-electrolytes, therefore will not conduct electricity. On the other hand, ammonium hydroxide, that is NH4OH, is a weak electrolyte and NaOH is a strong electrolyte. So 0.1 molar NaOH will produce maximum number of ions in the solution. As a result, will be the best conductor of electric current. That means the correct answer for this question is option number 3. Moving to the next question, students.